Hey, what's going on, guys? In this video we are going to see an example of inverse Laplace transform. Let's look at this problem. Here we have the function provided 3s minus 15 over 2s square minus 4s plus 10. Now here we have the quadratic formula in the denominator, but this is not perfect square, right? Because if you look at this one, this is almost matching this one, e power at cos bt or e power at sin bt, but we have to have the denominator in this form. We have to have a perfect square trinomial, but here we don't have that one. Okay, so we have to bring that pattern. To do that, what I'm going to do is I'm going to pick the common factors first. Here you can see this 3 is a multiplication. Like we can pick up this 3 and the denominator 2. If you do that, this is going to become s minus 5, and in the denominator we are going to have s square minus 2s plus 5. Okay, now we have this function. Now we are going to convert this one into one of these patterns. Now we have to deal with the denominator first. Okay, to convert this one into perfect square trinomial, what you do is you pick up the second value. Here in this case negative 2. Negative 2, then you multiply that one by half, and then you square the whole thing. If you multiply this one with half, that's going to be negative 1. Negative 1 square is going to be plus 1, right? So plus 1 is the thing we are going to add in the denominator. If you do that, this is going to become s minus 5 over s square minus 2s, and we are going to add plus 1, and if you add plus 1, we have to subtract 1, right? So this is going to be minus 1, and this is plus here, and that's it. Now let's simplify this one. This is going to become 3 over 2 Laplace inverse, and then here we are going to have s minus 5, and this is s minus 1 square, right? S minus 1 square, and here we are going to have 5 minus 1, that's going to become 4. Okay, now we have this value, and if you compare this one with the pattern, this one almost matching with the cos pattern, because in the cos we had to have s minus a square in the denominator, and we had to have s minus a in the numerator. Since we have s on the numerator, we know that this is going to be cos pattern, and to get the cos pattern we had to have this s minus a value. This is our s minus a value. We had to have the same value in the numerator, but here we have s minus 5. To bring this one into this pattern, what we can do is we can add 1, like subtract 1 and add 1 to bring that s minus a pattern. So that's what I'm going to do here. Let's continue here. Here we are going to have 3 over 2 L inverse, and then we are going to have s minus 1. This is what we want. If we subtract 1, we have to add 1. So we have to, this minus 5 is going to remain outside, and we add 1 to that, and in the denominator we are going to have s minus 1 square, and also we have to have b square. This is 4. 4 is 2 square, right? So 2 square, and then that's it. Now let's simplify this one. Here we are going to have 3 over 2 Laplace inverse s minus 1, negative 5 plus 1, that's going to be negative 4, and in the denominator we are going to have s minus 1 square plus 2 square. And if you compare this one with this pattern, until this point this is exactly the same, until this point, right? This negative 4 doesn't count because we had to have s minus a over s minus a square plus b square. We have this pattern here, but this negative 4 we don't have that one. So to get rid of this one from this one, what we have to do is we have to separate this. If we do that, we are going to have the whole denominator with this 4. So let's continue this part right here. Okay, here we are going to have 3 over 2 and then inverse, and after that we are going to have this s minus 1 over s minus 1 square plus 2 square. Now I am separating this negative 4, so negative 4 is going to come here, and then we are going to have the same denominator, s minus 1 square plus 2 square. Now this second one is matching with the sign pattern, e power at sin bt. We have to have b on top. In our case, b is equal to 2. This is the b value, right? This is our b value. So we have to have 2 on top. to get 2, what we can do is we can multiply by 2 and divide by 2, and we can move this 4 to the front. If we do that, okay, let's go ahead and do that. This is going to become 3 over 2 L inverse, and then we are going to have s minus 1 over s minus 1 square plus 2 square, and here we are going to have 4 times, we can move the 4 to the front, and then we are going to have 2 over 2. This is same as 1, right? So 2 over 2, we just have to have 2 because we just have to have b. This denominator 2, we shouldn't have that one right here, so we can move that one with this 4. So if I move this one with 4, this is going to be 4 over 2. That's going to make this whole thing 2, because 4 over 2, that's equal to 2. So instead of writing like this, we can directly put 2 right here, and the denominator is going to remain the same. That's going to be s minus 1 square and plus 2 square. Okay, now we can go ahead and write in this pattern, because we have brought these two in this pattern. For this one, our a values, the value subtracting from s, in our case that's 1, and b values, this value, in our case that's 2. For this one, a value is 1, b value is 2. So for both of them it's same value. So we can, let's go ahead and write the Laplace inverse. For this one, this is going to be e power, a is 1, so this is going to be just e power t, and then cos bt, cos 2t. Okay, and also we shouldn't forget this 3 over 2, this multiplies the whole thing. Okay, this one and the other one, and here we are going to have negative 2, and then this one is going to become e power at sine bt. In our case a is 1, so this is going to be just t, then sine bt sine 2t. Okay, that's it. Now if we multiply 3 by 2 for this one, this is going to become 3 by 2 e power t cos 2t, and this one is going to become just 3, right? Just 3 e power t sine 2t, and that's going to be the Laplace inverse for this given function. And that's how we do this kind of problems. I hope this helps. Thanks for watching.